Good morning, everybody. My name is Ferhan Mazher, and today is 30th November 2020, and I am with the 10 Matric girls class. And today we are working on physics, and this is chapter number 15 we are working on, and we are working on the transformers. And we have already done one session on the transformers. This is the second session on the transformers. In this, we will be learning about few equations and which are being used in the case of a transformer, and we will solve some numericals which are in your syllabus. And we are talking about the smart syllabus for this year. So we have already learned that what is a transformer. A transformer is a practical application of mutual induction. Transformers are used to increase or decrease AC voltages. Usage of transformer is common because they change voltages with relative little loss of energy. In fact, many of the devices in our homes, such as game systems, printers, and stereos, use transformers for their working. A transformer has two coils electrically insulated from each other. Don't forget this sentence, okay? A transformer has two coils electrically insulated from each other but wound around the same iron core. One coil is called the primary coil. The other coil is called the secondary coil. Number of turns on the primary and secondary coils are represented by NP and NS respectively. So don't forget this thing. Capital N and P with as a subscript, and capital N and S as a subscript. NP means the turns on the primary coil. You can count the turns, whether there are 10 turns, 5 turns, 2 turns, 200 turns, or 2000 turns. So how many turns are in the primary coil? And NS means the number of turns in the secondary side or in the secondary coil. When the primary coil is connected to a source of alternating voltage, the changing current creates a changing magnetic field, which is carried through the core to the secondary coil. In the secondary coil, the changing field induces an alternating EMF. The EMF induced in the secondary coil called the secondary voltage, Vs. Voltage which is in the secondary coil, which is induced, that is called Vs, is proportional to the primary voltage Vp. The secondary voltage also depends on the ratio of the number of turns on the secondary coil to the number of turns on the primary coil as shown in the following expression. So remember, Vs by Vp, never forget this equation. Vs by Vp is equal to Ns by Np. You see, this diagram, the small diagram on your screen, this diagram, let me increase the size so I can show you that diagram. Let me show you that diagram. Okay. This is the primary coil and this is the secondary coil. In the primary coil, we have provided the alternating current. The alternating current, or we normally call it AC current. The direction of the AC current is continually changing. It flows in one direction, then it flows in the other direction, then it flows in this again in this direction, then it flows in the other direction. So we call it the alternating current. The EMF is alternating. In the primary coil, we have connected it with a alternating current, AC current. Because the direction of the alternating current is changing, so the primary coil here, it becomes electromagnet, and because the current flowing through it, its direction is changing. So the electromagnet which is produced on this coil, its polarity is also changing. I mean that if this side is north and this is south, when the direction of the current will change, the polarity of this magnet will also change. So now this will become north and this will become south. Try to understand this point. When you provide alternating current in the primary coil, the electromagnet, the primary coil becomes electromagnet, that the polarity of that electromagnet is also changing. So in one moment, if this lower end is a north, in the second moment, this will become south. So this is north, this is south, then this is north, and this is south. You see, the polarity of that magnet is changing. When this lower end is north, the magnetic lines flows in this anti-clockwise manner. And when this upper side becomes north, the magnetic lines will flow in the clockwise manner. You see, the magnetic lines, due to the alternating current in the primary coil, the magnetic lines which are flowing in the iron core, they are also changing. So due to this changing magnetic flux, due to these changing magnetic lines, because the magnetic lines in one moment they will be flowing anti-clockwise, and in the next moment they will be flowing in the clockwise manner in the iron core. So the magnetic lines which are passing through the secondary coil, it means they are changing. Once they travel anti-clockwise, and the next moment they travel clockwise. So the magnetic lines which are passing through the secondary coil, they are changing. Their direction is changing, their magnitude is changing. Due to this changing magnetic lines, due to this changing magnetic flux which are passing through the secondary coil, EMF is induced in the secondary coil. When the EMF is induced in the secondary coil, that can be taken out and can be used. That is the output of the transformer. You see, the EMF which is induced in the secondary coil, that is also alternating current. Do you understand this idea, the whole idea which I just told you?
Yes, sir.
Hmm.
Sir,
That will
sorry
be
to
lower Sumida, sir.
appreciate, you know.
Hello? Hello?
जी सर.
Okay. Now,
Yes, sir.
remember this. This equation is very, very, very important. We have a relationship between the voltages and the number of turns in the coils of the transformer. So Vs divided by Vp is equals to Ns divided by Np. Okay. If you put the voltage of the secondary in the numerator, then on the other side, the number of turns of the secondary should also be in the numerator. Okay. You can see Vs, the voltage in the secondary is in the numerator. On the other side, the number of turns of the secondary, they are also in the numerator. So Vs by Vp is equals to Ns by Np. Very, very important equation. You will remember this.
जी.
Never forget
Yes,
it.
sir.
If the secondary voltage is larger than the primary voltage, the transformer is called a step-up transformer. This is a very important MCQ. If the secondary voltage is higher than the primary voltage, this is a step-up transformer. And if the secondary voltage is lower than if the secondary voltage is smaller than the primary voltage, the transformer is called a step-down transformer. This can be an MCQ, okay? If the secondary voltage is larger than the primary voltage, it is a step-up transformer. If the secondary voltage is smaller than the primary voltage, it is a step-down transformer. In the step-up transformer, the number of turns in the secondary are more than the number of turns in the primary. In the step-down transformer, the number of turns in the secondary are smaller or fewer or less than the number of turns in the primary. Okay.
जी
Okay. Now, if the secondary voltage is smaller than the primary voltage, the transformer is called a step down transformer. In an ideal transformer, the electric power delivered to the secondary circuit equals to the power supplied to the primary circuit. So remember this thing. The whatever is the power in an ideal transformer. We are not talking about the real transformer. We're talking about an ideal transformer where there is no loss of energy. There is no loss of power. The power in the primary and the electric power in the secondary, they both are equal in an ideal transformer. In an ideal transformer, the electric power delivered to the secondary circuit equals to the power supplied to the primary circuit. An ideal transformer dissipates no power itself. And for such a transformer, we can write the power in the primary. Let me increase the size. The power in the primary is equals to the power in the secondary. You know the electric power, we have already used this formula. The electric power is equals to VI. This is the formula for the electric power. So the power in the primary can be VPIP. The voltage in the primary multiply current in the primary. And the VS is PS is the power in the secondary that can be replaced by VSIS. VS means the voltage in the secondary and IS means the current in the secondary coil. Okay, now here we have an example given to us. If a transformer is used to supply voltage to a 12-volt model train which draws a current of 0.8 ampere, calculate the current in the primary if the voltage of the alternating source is 240 volt. Now, in this example, you can do this in your copy. First of all, let us note down what is the data which is given to us. He has told us that the voltage in the primary is 240 volt. VP. Voltage in the primary is 240 volt. The voltage on the output side or the voltage which is being provided through the appliance or the train, that is 12 volt. VS is 12 volt. The current in the secondary is 0.8 amp. 0.8 ampere. And the current in the primary is the question. So we will use the second equation which we just learned, that the IPVP is equals to ISVS. This famous equation. The input power of the primary is equals to the output power of the secondary. So I want to find out the current in the primary. IP is the question, so I will make it alone. And I will take that VP with it, which is multiplying here. When I will take it to the other side, it will divide there. So you see, IP will be equals to 12 IS value multiply 0.8 amp, the VS divided by the 240 volt, and the final answer, if you do the calculation, will be 0.04 amp. Do you understand this example?
जी
Yes,
सर
sir.
Okay. You see, these examples can come in your paper. They are very easy. The voltage in the primary was given. The current in the primary is question. The voltage in the secondary is given. The current in the secondary is given. And you use the second equation which we have learnt about the transformers, that the power in the primary is equals to the power in the secondary. IPVP is equals to ISVS. And I made the IP alone. So IS multiply VS divided by VP. Just put the values and do the calculation on your calculator. You get the answer. Please, beta, don't forget this. Very, very important example. And it can be in the paper because very simple, it's short, and it can be given of 2 marks. Okay. So this high voltage transmission, is this in your syllabus? Hello.
जी नहीं सर, ये वाला इंक्लूडेड नहीं है हमारे
Yes,
से।
sir. We included in
Th-
matter.
This is not.
जी सर, ये इंक्लूडेड नहीं है।
So this topic is not in your syllabus.
यस।
Application of electromagnets, that is also not in your syllabus. Huh? Okay. So we are going to the numericals, and let me go to the first numerical. This becomes too large. This becomes too small. Okay. So how many numericals do we have in our syllabus? First four?
Yes, sir. First four numericals are
Okay.
in our syllabus.
So the first numerical is a transformer is needed to convert a main 240 volt supply into a 12 volt supply. So do you see? The primary voltage is given. VP is 240 and the VS is 12 volt. If there are 2000 turns on the primary coil, NP is given 2000. Then find the number of turns on the secondary coil. NS is question. Do you understand this statement?
जी
Okay. So let me show you. I
Yes,
have
sir.
a solution also with me. Here we go. Okay. So VP is given, the voltage in the primary 240 volt, and the secondary voltage is also given, VS, that is 12 volt. The number of turns in the primary also given, 2000 volt, 2000 turns. The number of turns in the secondary is question. So we will solve it. You see, you just learned the formula NS by NP is equals to VS by VP. NS is question, number of turns in the secondary. So that NP will go on the other side and it will multiply. So VS multiply NP divided by VP. Just put the values 12 multiply 2000 divided by 240. And the final answer will be 100. So the number of turns in the secondary are 100. Do you understand this?
जी सर।
Bete,
Yes, sir.
will you note this in your copy?
यस सर।
Yes,
Just
sir.
this solution, just note it down in your copy also. Quickly.
ओके
Okay, sir.
Are you done?
So 2 minutes more.
Okay. Take your time. Take your time.
Done, sir.
Okay. So let's move to the next numerical. Numerical number 15.2. A step-up transformer has a turn ratio of 1:100. Okay, so try to understand this statement. A step-up transformer has a turn ratio of 1:100. What does this mean? It means that N NP divided by NS. NP is 1 and NS is 100. You understand this thing? It's a step up transformer. So the number of turns in the secondary will be higher. So if the NP value is 1, what does this information means? If the NP value is 1, the NS value is 100. Bete, do you understand this? This first
जी सर
sentence. Okay. An alternating supply of 20 volt is connected across the primary coil. So the VP, the voltage in the primary, that is 20 volt. The question is, what will be the voltage in the secondary? VS is question. So I hope this statement is clear to you.
जी सर
Yes, sir.
Okay, so let's go to the solution. So this second numerical. So NP is 1 and NS is 100. The ratio is given. NP ratio NS. So this means NP divided by NS. Okay, that will be 1 by 100. You know the idea of converting the ratio into fraction?
जी सर
Okay, so the
Yes, sir.
voltage in the primary 220 volt, the voltage in the secondary is question mark. So what we will do, we will apply this formula. So you can, you see, NP divided by NS is equals to 1 by 100. So VS by VP is equals to NS by NP. So I want to find out the VS value. So this VP value the VP will go on the other side. So we will have NS multiply VP divided by NP. You know, the this here I have NS by NP. NS by NP. Okay. The NP divided by NS means 100 and NP means 1. That is given the data. Na? And the VP value is 20. Just put those values there. NS according to the ratio was 100. NP according to the given ratio was 1. And the VP value was 20. Just put those values. And in your calculator, 100 multiplied 20 divided 1 and equals to. And you get the answer. That's 2000 volt. Do you understand?
जी सर समझ आ गई है
Okay.
Yes, sir.
Okay, kindly note this in your copy if you can do that. I'll give you 1 minute. When you are done, kindly tell me.
सर मैंने लिख लिया है
Okay.
Sir, मैंने भी देख लिया.
Okay.
मैंने भी कर लिया
Zainab is also with us. Okay. So that was numerical number 15.2. Now we will go to the numerical number 15.3. A step-down transformer has a turn ratio of 100:1. So try to understand this sentence. A step-down transformer. So here, in the primary, the turns will be higher. And in the secondary, the number of turns will be less number of turns. So the NP value is 100 and the ns value is 1. Do you understand this first sentence of this numerical? The statement of the numerical.
जी सर.
Yes, sir.
Okay. So a step down transformer has a turn ratio of 100 ratio 1. An alternating voltage of an alternating voltage of amplitude of 170 volt is applied to the primary. So the VP value is 170 volt. If the current in the primary is 1.0 milliamp, so the current in the primary IP is 1 milliamp or 1 milliampere. What is the current in the secondary? The IS is the question. Okay. So do you understand the statement of the question? What is the data given and what is the question asked? Do you understand?
Yes, sir.
Okay.
Yes, sir.
So now let's go to this numerical. Okay. In this numerical, there are two steps. Okay. The NS ratio NP is given. NS value is 1. The number of turns of the secondary is 1. The number of turns in the primary is 100. Okay. The voltage in the primary is 170 volt. And the current in the primary is 1 milliamp. Milli means 10 raised to power minus 3. So 1 milliamp means 1 expo minus 3 ampere. You understand this thing? Milli means 10 raised to power minus 3.
जी सर.
Okay. So I want to know what is the current in the secondary. The formula is Vs by Vp is equals, this is the first step of how you use it. Vs by Vp is equals to Ns by Np. The Ns value is 1 and the Np value is 100. That was given in the data. And I want to find out, first of all, Vs. This is not directly asked in the question, but we have to find it. The voltage in the secondary is not asked in the question, but we have to find it. Okay. So Vs is equals to Ns by Np multiply Vp. The Ns value is 1, the Np value is 100, and the voltage in the primary is 170. So just do the calculation. 1 multiply 170 divided by 100. Put these values in your calculator and you will get the answer 1.7 volt. So the voltage in the secondary now I know is 1.7 volt. Now you see, I know the voltage in the primary, that is 170 volt. I know the voltage in the secondary, that is 1.7 volt. I know the current in the primary, that is 1 expo minus 3 ampere. And we want to know the current in the secondary. So we will use that famous equation that the power in the primary is equals to the power in the secondary. This is about an ideal transformer. So, the power of the primary is equals to the power of the secondary. So IP VP is equals to IS VS. If you want to find out the value of the IS, the current in the secondary, take the VS to the other side, it will divide there. And then put the values. And on your calculator, you will enter 1 expo minus 3 multiply 170 divided by 1.7. So the answer will come out to be 0.1 amp, 0.1 ampere. So the current in the secondary is 0.1 ampere. You see, this numerical is little longer. If this numerical comes in the paper, it will be definitely it will come in the long questions, because this numerical can be of 4 or 5 marks. But do you understand this numerical?
जी सर.
Do you understand
Yes,
that
sir.
we have done it in 2 steps? The first
जी
step,
सर.
which apparently is not asked in the question, but we have to do that. Okay, you have 2 minutes. Kindly first of all do this first part in your copy, and then I will move it to the next part. Hurry up.
Okay, sir.
In this first part, we calculated the value of the Vs, which was not asked in the question directly. But we have to do this because I want the main question is what is IS, the current in the secondary. But that I cannot find directly. Okay. For an ideal transformer. Okay, are you done with the first part?
जी सर कर लिया
Okay.
Yes, sir.
And
Done.
then complete the second part.
Done, sir.
The whole thing is done.
सर मैंने दूसरा पार्ट भी लिख लिया अपने पास
Okay, okay,
सर मैंने भी लिख लिया है.
okay. Okay. Now we move to the next thing. And then we have this fourth numerical, 15.4. A transformer designed to convert the voltage from 240 volt AC mains to 12 volt has 400 turns on the primary coil. Okay, so try to understand this first sentence. A transformer designed to convert the voltage from 240 main AC mains. It means the primary voltage is 240. It means the primary voltage is 240 and the secondary voltage is 12 volt. VP is 240, VS is 12 volt. Has 4,000 turns on the primary coil. So the NP is 4,000. NP is 4,000. How many turns should be on the secondary coil? That's the first question. So the NS is the question. Do you understand this part of the statement?
जी सर समझ आ गया
Okay. If
Yes,
the
sir.
transformers were 100% efficient, what current would flow through the primary coil when the current in the secondary coil was 0.4 amp? The current in the secondary IS is given 0.4 ampere, and the current in the primary is questioned. IP is the question. That is the second part of the question. You see, this numerical is also such kind of numerical which can be a part of a long question. This numerical can be of 4 marks. This numerical might be of 5 marks. Okay. So these two numericals, 15.3 and 15.4, they can be a part of a long question. Okay. Now, okay.
Okay, sir.
So a transformer. So what is the data given? We have the voltage in the primary, that is 240 volt. The voltage in the secondary, that is 12 volt. And the number of turns in the primary, that is 4,000. So number of turns in the secondary is question. We know the formula NS divided by NP equals to VS divided by VP. That's the famous equation. Okay. You just put the values. I want to make the NS. I want to find out the NS. So I will make it alone. So that NP, which is downstairs, when it go on the other side, it will be upstairs. So we will have VS multiply NP divided by VP. So just put the values. 12 multiply 4,000 divided by 240. And the final answer will be, when you do this on the calculator, it will be 200. So the number of turns in the secondary are 200. That's the first part of the question. In the second part of the question, he says that the current in the primary is question mark, the current in the secondary is 0.4 ampere. The power in the primary is equal to the power in the secondary. So IP VP is equal to IS VS. So IP will be equals to that VP will go on the other side and divide. Just put the value 0.4 multiplied 12 divided by 240, and the final answer will be 0.02 ampere. Okay. Do you understand, Bete?
जी सर.
Okay. So just do
Yes,
this
sir.
numerical in your copy. That's the first. Just note down the data.
Okay, sir.
When you are
Okay sir.
done with this slide, then we can move to the next one.
Yes, sir.
You're done? Okay. When you are done with this, kindly tell me so we can move to the next thing.
Sir, done.
You're done.
सर मैंने भी कर लिया वाला part.
Okay. Okay. So, the chapter number 15, we are done with the chapter number 15, and we are also done with its 4 numericals and 1 example that was the part of your syllabus. And now, um, we have to do its MCQs. And do you know how many MCQs are in our syllabus?
Sir, MCQs सारे हैं.
MCQs?
I think there are all the MCQs included.
Yes,
All the
sir.
MCQs are in your syllabus, but all the topics are not in your syllabus.
Yes.
Sir, MCQs
Okay.
most of the time सारे ही दिए होते हैं.
Okay. So there are 9. Do you have your book in front of you?
जी सर.
Yes,
Okay.
sir.
So here we have that MCQs in front of the first MCQ is which statement is true about the magnetic poles? Opposite poles repel, like poles attract. Magnetic poles do not affect each other. A single magnetic pole does not exist. Opposite poles repel, that's wrong. Like poles attract, that is also wrong. Magnetic poles do not affect each other, they affect each other. That's the C option is also wrong. D, a single magnetic pole does not exist. That is right. It is never possible to have a North Pole only. And it is not possible to have a South Pole only. Wherever you will have magnetic poles, there will be always a North Pole and a South Pole. Okay? So D is the right choice. Do you understand?
जी सर.
Okay. The number 2 is what is the direction of the magnetic field lines inside a bar magnet? This is a very tricky question. Remember, outside the bar magnet, I'm saying outside the bar magnet, the magnetic lines move from north to south. It's a famous diagram. You must have studied it. But inside the bar magnet, the magnetic lines travel from south to north. Outside the bar magnet, the magnetic lines move from north to south. But inside the bar magnet, the magnetic lines travel from south to north. So the question is, what is the direction of the magnetic field lines inside a bar magnet? Let me open it so you can see a larger version of that thing. Okay. So I can increase the size. Okay. What is the direction of the magnetic field lines inside a bar magnet? From the pole of South Pole? From South Pole to North Pole? That's the right answer. From side to side, there are no magnetic field lines. So B is the right answer, ma'am. Do you understand this?
Yes, sir.
Yes, sir.
जी सर।
Okay. The third question is the presence of a magnetic field can be detected by, we have magnetic compass. With the help of the magnetic compass, we are able to tell the magnetic lines are uh, here or not. The presence of a magnetic field can be detected by a small mass? No. Stationary positive charge? No. Stationary negative charge? No. Magnetic compass? Yes. So D is the right choice. So for question number
ओके
3, the
सर।
choice is D. You understand?
जी सर।
The fourth one, if the current in a
Yes,
wire which
sir.
is placed perpendicular to a magnetic field increases, the force on the wire that will also increase. Okay, so A is the choice. A is the right choice. Have you marked it on your book?
जी सर कर
Yes,
लिया
sir.
मार्क।
Okay. DC motor, which was not in your syllabus, but its the MCQs are included in your syllabus. A DC motor converts the electric energy. What the motor do? It convert the electric energy into mechanical energy. Remember, it uses the electric energy and it gives you the mechanical energy. A DC motor converts mechanical energy into electric energy? No. Mechanical energy into chemical energy? No. Electric energy into mechanical energy? Yes. It converts the electric energy into mechanical energy. So C is the right answer. C is the right choice for question number 5. You understand?
जी सर।
Okay. Which part of a DC motor is reverse the direction of the current through the coil every half cycle? This concept was not included in your smart syllabus, but the MCQ is included. We call it the commutator. We call it the commutator. Remember this name, which in the DC motor, the part which changes the direction of the current during every half cycle, that is called a commutator. Okay, just remember this. The armature, the commutator, the B is the right choice. B is the right choice. Just remember this thing, okay? Seventh one, the direction of induced EMF in a circuit is accordance with the conservation of mass, charge, momentum, energy. Is the energy. The EMF, the direction of the induced EMF in a circuit in accordance with the conservation of energy. Okay, so D is the choice. Okay. Number 8, the step-up transformer. The step-up transformer, what the step-up transformer? The secondary voltage will be more than the primary voltage. Step-up transformer. Increase the input current? No. Increase the input voltage? Yes. He has more turns in the primary? No. Has less turns in the secondary? No. Whatever will be the input, the output voltage will be more. So it increases the input voltage. It's a little tricky wording, okay? So B is the right answer. You understand?
जी सर।
Yes, sir.
The turn ratio of a transformer is 10. It means 10 means 10 by 1. Remember this thing, this idea. 10 means 10 by 1. 10 means 10 ratio 1. It means that the number of turns in the primary is 10. See, it says the turn ratio of the transformer is 10. You see, he says that the turn ratio is 10. It's little tricky.
So in this MCQ, he has not told us what kind of a transformer it is.
Hello?
In this transformer, in this MCQ, he hasn't told us what kind of a transformer it is.
Yeah, that's a big problem. So the turn ratio is, he choose C, but if the turn ratio, see, let me make it more clear to you. You see, if I show you this, the third one, you see, a step down transformer has a turn ratio of 100:1. So this ratio is basically 100. So it will be number of turns in the primary ratio number of turns in the secondary. Okay. So I don't agree with this answer. Okay. So it means that the voltage in the so number of turns in the primary divided by number of turns in the secondary is equals to 10/1. Let me show you. Let me write it so you can understand what I'm saying. Here I can write something. Can I write here? No. Let me take out paint so you can understand it clearly. Okay. Try to understand. Okay. So number of turns in the primary ratio, number of turns in the secondary is equals to 10. Oh, it should be like 10:1. So that will be NP divided by NS. That should be 10/1. So if I will make NP alone, it will become 10 NS. Okay, let's check what the answer we have. What are the options? NP is equals to 10 NS. Do we have this option? If I make the NS alone, let's see what happens. Okay, if I make this NS alone, let me change the color. So final answer will be, if I make this NS alone, you see, if I make the NS alone, if I will make this NS alone, it's very difficult to write in paint. We don't have that. This 10 will go on the other side, it will divide. So it will become NP divided by, you see, 10. So NS will be equals to NP divided by 10. NS will be equals to NP divided by 10, sorry. So I think NS will be equals to NP divided by 10. I think the B should be the choice. Here, this B should be the choice. He said I think the B is the choice. Let me clear it. Let me go to that. Uh, Let me find that sentence. Okay. Hmm. Hmm. The number two on the primary and the number two are required by. He's used the word ratio. So, according to my, you can also confirm it somewhere, but I think the B is the right choice. Okay. Hello.
Yes, sir.
So, I think we are done with the MCQs also. So, bete, my idea of preparing for the matric exam is that whenever you prepare a chapter, the first thing you prepare is its MCQs, then you do prepare the examples, then you prepare the numericals, then you prepare the definitions, and then you prepare the short questions. This is the order of the preparation. And the long questions are at the end. Okay? Never forget this thing. So I think
Okay, sir.
our time is about to over. So today, I just want to know how many of you are present with me. But we can do this after I stop the recording. So thank you very much. My name is Ferhan Mazher, and today is the 30th of November 2020. I was with the Matric class. We are in this video. We have done numericals or related with the transformer. This chapter number 15, and we are also done with we have done with the MCQs of this chapter. So I hope you all have understood everything. So thank you very much and have a good day and God bless you all.